The word distribution refers to where points' values are. Are there mostly high values or low values? Are the points tightly clustered around some number or are they all spread out? If we draw what's called a histogram of the data, it'll show us the data's shape, which we can use to help direct our analysis. We draw a histogram by putting data into bins. Here we have a data set of 71 chicken weights. They range from 108 grams to 423 grams. What I'll do is break up this range into bins and put the data into them. I'll make 7 bins of size 50 ranging from 100 to 450. Here are the bins. The histogram consists of bars whose heights correspond to the numbers of elements in the bins. There are 7 chickens that weigh between 100 and 150 grams. We put 7 in the first bin. 10 in the second bin. We draw a bar of height 10. The third bin has 16. Notice that I put 250 in this bin. That's the way R does it. I could have written the bins like this. If you recall the interval notation with the round and the square brackets, it doesn't really matter how we break these up though, because we don't expect continuous data to hit any specific point, and this graph is not meant to be really precise. It's meant to give us a kind of a rough idea of the shape. So we just need to make sure no one point winds up in 2 bins. Next we have 12, 17, 7, 2. And now we can examine the shape. These are the shapes we're looking for when we examine a histogram. This bell-shaped plot is called normal, referring to the normal distribution, which we'll cover in a couple weeks. In a normal distribution, the mean, median, and mode are all the same. And the distribution is symmetric about its mean, so that this side is a mirror image of this side. Right skewed data is data that has a tail on the right. Most of the data is over here, but there are a few higher values over here. With right skewed data, the mean is higher than the median because these high values drag the mean up. Left skewed data is the opposite. Now the tail is on the left. The data is concentrated here, but there are some lower values here that drag the mean down. With left skewed data, the mean is lower than the median. We see a uniform histogram when all of the bins have the same number of elements in them. In a uniform distribution, you're just as likely to draw one number as any other. Compare it to the normal distribution. Like the normal, the uniform is symmetric about its mean, and the mean equals the median. But if you draw a number from a normal distribution, you're most likely to get something that's close to the mean, and not as likely to get something far away. But with the uniform, you're just as likely to get something far from the mean as close to it. Next, we have bimodal and multimodal. The mode is defined as the most common element of a data set. We say that a histogram is bimodal when it has 2 prominent peaks, and multimodal when it has more. Keep in mind that these peaks don't have to be exactly the same height. Multimodal means that the data is concentrated in different spots. This here is an idealized normal distribution. Real life data is messy, so you're rarely going to see data that looks perfectly normal like this. This is a histogram I'd categorize as normal. You see it's not a perfect bell shape, but of all the shapes we looked at, it's closest to the normal. This is some simulated data of IQ scores. IQ is something that tends to be modeled as normal with mean 100. If you randomly draw someone from the population, they're likely to have an IQ that's near 100. It's very unlikely that their IQ would be above 130 or below 70. Income is something that's often right skewed. Most people make about the same, but there are some high earners that skew the distribution and cause the mean to be greater than the median. For that reason, when people are looking for a typical household income, they often use the median as the measure rather than the mean. And this is some data I found on baseball players' salaries. Most players make less than $2 million, but the mean is $4.5 million. Here's a left skewed distribution. You see that the life expectancy in most countries is in the 70 to 80 range, but there are some countries with really low life expectancy and they drag the mean downward so that the mean is less than the median. This is fairly lightly skewed because the mean is only a little lower, but this difference might be significant when you're talking about life expectancy. Remember that the modality of a histogram refers to how many peaks it has. The last three distributions we looked at each had one prominent peak, so that would make them unimodal. A bimodal histogram has two peaks. A multimodal histogram can have several peaks. A multimodal histogram suggests that the data belong to several different groups. Here's a multimodal histogram of iris petal widths, and if we break it apart by species, we can see that these peaks are coming from the fact that there are three separate species of iris. Here's a distribution that's approximately uniform. Remember that real data likely won't be perfectly uniform, but a histogram like this would make us think that the data came from a uniform distribution. One interesting thing about the uniform distribution is that while it's symmetric so that the mean equals the median, neither the mean nor the median is particularly good at summarizing the data. This is because the values are just as likely to be far from the center as close to it, but we can actually summarize it pretty well with the minimum and the maximum.